Tonight, we have the pleasure of having John Scott, a glass app developer who has a platform of Context Aware, and John's going to tell us about a little bit about his background and exactly what the platform is. Also with us is Dave Martineau, a hand surgeon from Dayton, who Dave and I will ask John questions after. And okay, all right, John, it's not real formal. This is a fun time to learn. Okay, welcome, John.
Sure, thank you everybody for joining us tonight. I'll tell you a little bit about the product that we have developed. The product is called Context Surgery. You can check out our website if you're interested in more details, contextsurgery.com. The entire design basis behind Context Surgery is a context-aware computing platform. The point that we're driving towards in our design is to provide the right information at the right time and the right place to surgeons while they're in the OR and throughout their clinical practice. One of the things we discovered early on with the glass device or any other wearable smart glass technology is that too much information or out of context information or information that was presented at the wrong time could be distracting or confusing to surgeons, and that of course would not result in a good outcome either for the patient or for the operating room staff. So we've emphasized providing this information in a glanceable format. The experiences that Google's Explorer program has produced over the last couple of years, the results of that has been that Google itself in their design documents on the developer website emphasized that this is a glanceable display format. The average user looks at the display from about 1 to 3 seconds on average each time that they want to access information. So this is not the kind of display that you stare at like you would a laptop or a tablet or even a phone. For this to be effective, you have to take into consideration design sensitivities like use of colors, use of audio alerting, providing minimal information but important information. So that kind of gives you a little bit of a high-level overview of our product, and then I'll kind of open it up to see if John or if Dr. Martineau had any input on that.
I mean, I think that's really key. I think it highlights or hits on the emphasis for what I think Google is trying to do with their glass device as far as making it a very glanceable, not all immersive type distracting device. It's there to help you, and it provides surgeons with a unique opportunity to actually utilize this in the sterile environment in the OR. But the last thing you want is having something that's just binging and going off and flashing stuff at you all throughout the case, being distracting. And at the same time, you actually want to have it display useful information. And I think with what Context Surgery is doing, it's perfect for the surgeon. It's perfect for this application, and it's gonna. I think it's really going to take glass from its current state, which is something that has great potential, actually to something that's going to be very useful. Because right now, all the discussions that I've had with people with regards to glass, it's more about what it has the potential of doing. So yes, I think it's going to be great, but it's not there yet. And I think with Context Surgery, it's going to take it there.
Well, you know, I think this is going to be a huge field. We were talking about that before we started. I think it's just starting. And when I first started getting involved and kind of getting hold of people like John and stuff that are using Google Glass and doing apps, I thought it was strictly a niche type of thing for surgeons. But the more I see it, and probably the more I hear from John about it, the more I see it's going to have wider applications, the more specific it gets. It's like it's not one size fits all. I think a hand surgeon is going to be, you have different uses and different designs than an interventional cardiologist. They're going to be probably, I bet they're going to be a different shape, and they're going to have different programs, different applications. Now, what kind of, Dave, as a hand surgeon, what kind of things, information do you want to see on the, what kind of things are in context, the kind of
So,
information you see?
which there's certain things that are required that throughout every case, for example. So, a lot of cases that involve broken bones, to keep it basic, you need X-rays and possibly CT scans or even MRIs that show you the pathology and help guide your decision making in the operating room. Currently, you have to have these X-rays either hung up on a view box across the room or on a computer somewhere, a computer monitor somewhere across the room, and so having those available to you at a glance when you need to remind yourself which fracture fragment piece you need to go look for, make sure you get it in the right position, make sure you're not being fooled by what you think you're looking at. It's very helpful to have that at a glance. Now, at the same time, there may be other instances, alerts, and things that come across that you would want to be notified on at the right time when it would permit, and such as issues with the patient's vital signs and the vital sign monitoring. If there's any alerts that they're problematic, they could come across on your glass so that they could alert the surgeon, hey, whatever you're doing, you may need to hurry it up, or you may need to stop and sort of address the issue with the anesthesiologist if there's a problem. And then there are other sort of perioperative issues that arise all the time, believe it or not, that can be very disruptive in the operating room. And there's really one of two ways currently to deal with it. It's either you tell your staff no interruptions, and anything that happens during surgery gets pushed off till the case is over, and that can often result in either significant delays, inefficiencies, and even the potential for patient compromise for if they're trying to get a hold of you because there's a patient you did surgery on who's having some sort of complication. You may be costing that patient valuable time by not addressing the potential issue while you have the chance during surgery. And so to have a context-aware platform that knows what alerts and what issues are important, which ones that could potentially wait until the case is done, would be extremely valuable not only for a patient care standpoint, a quality standpoint, a value standpoint, and an efficiency standpoint. And so those sorts of things are going to be very helpful and very unique when it comes to this application.
Yeah, one of the things that you commented on earlier, John, about that various different disciplines within surgery would have different profiles of usage, different things that would be important to them, something that might be important to a vascular surgeon that may differ from something that would be important to a surgeon of a different discipline. And what the key differentiator, I think, that we're finding is that no single app really can handle that. So you can, you have to remember that the glass device is a very small processor, very limited resources. It's mostly an interface, really, a display, a camera, a microphone with the ability to do and the basic processing power to be able to do voice-to-text recognition and things like that. But really, to unlock the true potential of that device, you really need a platform that can take into account the various modalities of use, what's important, what's relevant at any given moment, and that is the whole key, really, to being able to unlock the device's true potential. One of the things also that I'd touch on is the issues of HIPAA compliance. So we have built technology that allows the device to be HIPAA compliant, not only the device but the computing system, the context-aware computing platform behind that. It's cloud-based. We use all secure facilities. We encrypt all information that comes from or goes to the device when it's in flight. We also encrypt any data while it's at rest, whether it's at rest on the back-end platform, and when I say at rest, I mean stored, whether that's stored in memory, whether that's stored on disk, or wherever, whether that's stored in a cache. The other aspect is this platform that I'm alluding to has to be able to interface many different things. You know, I think you're going to be hard-pressed to do that with an app running on the device, right? So if you don't have a platform, you're going to have a rough time being able to interactively interface electronic health record systems, medical devices, etc. So those kind of capabilities are borne out traditionally in information technology by what we call middleware or integration software. And that's actually a strong suit for myself. I have spent the last 17 years of a 35-year career in software development in that space, developing middleware, integration middleware to connect together disparate systems. And then about the last 5 years, I've focused on context-aware computing and mobile wearable technology, specifically wearable technology, and even more specifically smart glass technology. Mm-hmm. The interesting thing is that there is an intersection between context-aware computing and these wearable devices. The intersection comes in the fact that in order to form context, you need information, right? So you need information on proximity, where are you? Temporal, what time is it? And what are you doing? And the sensors in Google Glass and other wearable technologies can provide pieces of that puzzle that allow you to derive the context at any given moment. We also use other external sensors in the actual operating room environment and throughout the clinic in order to detect where a physician or a surgeon is at a given time. If we relied purely on their schedule, as David, I'm sure, can appreciate, there's very few days that your schedule actually matches what's on the piece of paper or in the computer.
That's
so
right.
What we do is we take into consideration, where is he? If he's in operating room 2, but his schedule says he's supposed to be in patient room 3, doing a pre-surgery consult with a patient, then you need to provide him the right information. You don't want to be pushing him information for one case when he's still working on another. So those are some of the things that our context-aware computing platform take into account.
So just one quick point from what you just said. Do you have to actively have someone pushing information to someone like Dave in the operating room?
Yeah, that actually is the whole point of the system, to do that automatically. We also, however, are working with device manufacturers that allow us to remotely, if it's relevant to a particular surgeon's discipline and situation, circumstance, to allow someone else to help him to have information that they can see on wide screens from monitoring devices or from imaging devices to help put that information in front of him at the right time. So that's like literally having an assistant have the ability to control his glass device and be able to forward information to him quickly. And the other side that's interesting, and we'll get into a little later, I'll go ahead and let you ask your question, was telemedicine, and where we get into the applications of remote teleconsulting.
Right. Yeah, I was going to ask you about that. You mean like Dave could call a vascular surgeon and have him consult on his glass?
Yeah. So the idea there is that there's a couple of different things, aspects to this. One, if you look at a remote teleconsulting application, for example, we're engaging with one of the founders of the trauma programs around the country, and he's back in 1983 founded the trauma protocols for for a state, and then that was mimicked by another state, and then it kind of spread across the country, and then went international as well. So, he has a very deep background in trauma, and what we're doing in that case is we're literally helping him in an initial pilot test program to set up 57 trauma centers throughout the state, and be able to have a trauma surgeon at the medical center be able to remotely reach out to a trauma physician in a remote area, and for the surgeon at the medical center who is doing a live consult to be able to see exactly what the remote physician or surgeon sees and advise him accordingly. So that's one interesting thing. And then the other way is where you might have a scenario where a surgeon remotely wearing glass can, now we switch into everything we've talked about to this point has been augmented reality, right? Augmented reality is where you're immersed in the reality around you, and you have augmentation, information being displayed to you that you can glance up and look at, and it's augmenting. Virtual reality, however, is where you literally are providing a virtual reality experience where, for example, to give you the best example that really explains that, if you could put a physician, say, in Atlanta that was assisting a orthopedic surgeon like David in Cincinnati in a situation where he could put on a device and he then would see everything that David sees while he's in the OR. And there was a sensing device, a camera, that would be able to basically record the movement of his hands, if you will, into the field of surgery. And I don't know if I can quite emulate that on the screen here, but it would be like this. So then David would see the remote surgeon's hands and instruments come into his field of vision and begin to be part of, describing to him a technique or what he should do or what instruments he should use. And that's actually based on some technology that was perfected for the Department of Defense, actually, and directly applicable here. The nice thing is that it's completely HIPAA compliant because it actually, the same underlying technology fits MIL ComSpec requirements, which are well in excess of HIPAA standards for information security.
Very, very good. Now, do you have to? How close do you have to get with? I guess, have you done more than one specialty with the context, or
yes,
like you have to sit down with each specialist to say, okay, what kind of information do you consider to be contextual? What kind of information do you want?
That's a very good question. So one of the design or one of the software development philosophies that we have, that we discovered early on, in fact, was that by embedding medical experts in their specific disciplines, surgeons, physicians, whatever, and we are completely focused at this point on surgeons and surgical use in an OR and a surgical clinic environment, but we could easily extend the same platform out to a physician clinic environment. But the idea is that we embed surgeons in our development process. And when I say that, you say, well, what does that mean, embed them? Well, it means that literally they have the best idea of what would be useful. And so when we ask them to help define use cases for the technology, they are also the most logical person to test this technology and to, in fact, be, as we go through our agile software development process, to actually be the people that functionally own the deliverable features, and to say, look, that meets the acceptance criteria that I was looking for, or no, it doesn't, go back to the drawing board. And so by doing that, we have a quick turnaround time. We can rapidly execute on our development and build out the features that are needed, and we can also, as you mentioned, address the specific requirements and the specific nuances of each surgical discipline.
That's why I think this field is glass app field is going to grow tremendously. The more the glass becomes ingrained into medicine, I mean, not every doctor's going to use it, I don't think, but a lot of specialties are going to use it. And like you said, every specialty is going to be different, and even the shape of the glass will be different. Some people will have more of a stress on the visual part, and some, like surgeons, some will have more of a stress on the information part, and they won't need a camera as much. So I think it's going to be a field in your area, John, of doing glass apps that's going to really be booming.
Well, I think the thing to keep in mind is not just a cool technology that's going to be nifty and look what we can do. I mean, it's actually going to add real value to healthcare. I mean, it's going to, the things that he's describing with these virtual augmented assistants, to have the right key critical information at the right times. I mean, it's actually, all this would be for naught if we didn't have the patient in mind, and I think that's what is really driving a lot of this technology, including the contact surgery, is how do we add value to healthcare in general and to the patient experience, because ultimately that's what we're here for, and I think this does do exactly that.
Yeah, absolutely. If someone asked us what we're about, we have a very simple statement. We believe that the work that doctors do is important, and that the outcome for their patients is of the utmost importance. And so that's our job, basically, is to assist in any way we can to increase the quality and reduce errors and make the patient's experience better.
Have you? Who else have you worked? Have you worked with other? You work with Dave, who's a hand surgeon. Have you worked with any other docs, John?
Sure. Yeah, some I'm not completely at liberty to talk about because we're still in the process.
No problem. No problem. I understand that.
And signing deals with them for long-term development. However, I can tell you generally the areas. So we're currently engaged with a neuro scientist that is involved in deep brain stimulation and acts as a really fancy surgical technician to a brain surgeon to do implant, and literally feeds data to that surgeon on the angle necessary for the optimum insertion for some deep brain stimulation, and that's very exciting stuff. And in fact, his comment, he's a PhD, right, but he's essentially assisting a surgeon in his job, and his comment was, down the road, I see the potential to do away with my job. To literally be able to have the system provide the information directly to the surgeon and even do a potentially better job, because I am human and I can make mistakes. So that's kind of interesting, and then of course he laughed because he said that would be great because being a PhD, there's a lot of other things I'd like to do other than calling out numbers 3-4 hours a day to surgeons. It's fascinating work, but after you've done it for many years, it's actually pretty pedestrian. So
yeah, things are happening fast, and the shape, like I said, the shape of glass I think is going to change. The way it's going to be used is going to change. And really, John, I think I may have talked to you about this before, but and I don't own any stock in Google Hangout, but it's going to be a great way for you to get together with people like Dave or other docs, and Dave gets done, or a surgeon gets done, or a doc gets done. He jumps on his computer and says, "John, you know what? I really want to do this, and I can't do that." You know what I'm saying?
Absolutely, and I'm looking forward to the day when we can have live translation on the fly in these Google Hangouts, so that I can actually reach out. Our product is, we're all veteran software developers, right? We've decades of experience. The clients in the past that we've had are all global corporations, right? So when we develop software for them, they're like, this is going to work in any language on the planet, right? It's just a matter of doing the translation, and then your software will be able to switch in different character sets, right? And we of course respond with the correct answer, which is absolutely. Anyway, there's ways of instrumenting computer software to do that. It's called localization. So we take advantage of that, and within 6 months of our general release, which we're targeting for February of 2015, are full GA. We're in beta until then, and then in alpha later, just before the GA release or general availability release. Within 6 months of that, we intend to be out in 6 languages, in addition to English. And then 1 year from our GA release, we will be able to deploy our product in 26 countries around the world. So definitely looking forward to using Google Hangouts to reach out to other doctors and physicians and surgeons and find ways to meet their needs and tailor our product to do things that maybe we haven't thought of.
Yeah, we had Pedro Guillen. I don't know if you saw him the other night. He's a Spanish orthopedist that uses Google Glass in some of his orthopedic surgery, and he transmits a lot to different universities through his Google Glass. He teaches, but and also I don't know if you've heard of Droiders. It's a big glass app company in Madrid.
I've heard of Droiders. They make apps for Android, and they're very, very outstanding company. I've seen some information on their Glass app, but I don't know that they're doing any kind of platform or any kind of cloud-based solution. It seems to be just an app, a standalone app, if you will.
Okay, yeah. I think they just came out with one for dentists today, an app for dentists to use. I think, like you say, it was just an app, not a platform. But certainly, and that's one thing that surprised me, the surprising strength of the Spanish community in Google Glass and medicine, not in anything else but medicine. I was surprised.
I very much have been pleasantly surprised as I've begun to see the amount of activity coming from Spain. In fact, when we were at the Google Developer Conference couple of weeks ago in San Francisco, the place I was staying, I ran into the CEO and founder of a technology startup company that has some very innovative technology that we're actually probably going to use. It'll be one of the pieces of the puzzle. And he and his wife had just started up the company, and he was here in the Bay Area, of course, to go to the developer conference, but also to reach out and make contacts and things like that. And we had a couple of very enjoyable conversations talking about the Spanish ecosystem for med and med tech. Definitely a lot going on.
Do you want me to guess to see who that was? I won't. But I did have a hangout with a company called TEDcast that does virtual, not virtual. They do live motion, where the surgeon, Dave, you may know about this, where the surgeon can motion with his hands to move the radiological studies. I think it's, is it called live motion?
He's using Leap Motion. So he's using Leap Motion technology for that, which is an innovative use for that for sure. But I would just contest, what if you had a platform that was smart enough to know when you needed to look at those images and which images you needed to look at without having to even wave your hands? That's where I think we have the ability to head. So.
And then also to complement what David said, we do feel that when gesture recognition is useful, that it needs to be more than one technological solution, because there are all sorts of, each gesture recognition technology has its limitations in certain environments. So if you get into an environment where someone that has a gesture recognition technology that uses motion tracking, for example, if you are using your hand to move back and forth to control what you're seeing on your display, that's probably not going to work very well when you're in surgery, because there's a lot of hands involved and the surgeon's looking down and it's using the camera to pick up the motion detection. So what if the nurse comes in to irrigate the area and the device picks up her hand movement and it picks up a false reading? So there's a combination of different things. Moverio has a product that is worn on the arm, and it uses the movement of the muscles as you change the position of your hand to detect. That's useful in certain areas. In certain areas, it's cumbersome. And so the answer to it is that it'll be a hybrid solution. And as David mentioned, it's why do it in certain cases if the platform itself can understand what you need and get the information to you? Isn't that better than, as you mentioned, having to wave your hands around or try to use verbal commands that the device has to recognize? The easiest thing really would to be able to understand what you're doing and what you need and give it to you without you having to do anything. So.
Okay. Let's see. Do you foresee? Well, we have computers, laptops, desktops. Now a computer on the wrist. Do you foresee any other part of the body that the computer may go to besides being worn on the head, shoulder, or I know maybe that's a wacky question, maybe.
Well, it's not really, and let me tell you the high ground answer to that. It's going to be a hybrid of many things. I think that the technology that we have today are telltale signs of what we'll have in the future. But just because Google Glass comes out, or just because another manufacturer enters the field, maybe Samsung comes up with Samsung Galaxy Glass or something like that, doesn't mean that people are going to stop using their tablets and their iPhones, right? And their Android phones. So what I see is a hybrid of all those things, and it has to do with what is appropriate to use at the specific time. So if you are in a certain circumstance, using a tablet, here you go, here's a perfect example. Using a tablet or a smartphone is not an option if you want to film something while you're skiing in a snowstorm and post it to social media. I used Google Glass last year when I was skiing on Mount Hood here in Portland, just to see if I could do it, and it worked. It blew me away. I put it under my goggles. I've got some Oakley goggles that are the ones with the replaceable lenses, so they're larger and they tend to work well with over-the-glass applications for prescription eyewear. So I gave it a shot, and sure enough, my fiance and my best friend were out in front of me. We were doing a powder shoot, and it was a full-on blizzard, and I said, "Okay, Glass, record a video." And 10 seconds later, the video clip ended, because it's just configured to do that by default. And I said, "Okay, Glass, share with my friends." Boom, off it went. Oh. Had a buddy hit me back a few minutes later. "Are you kidding me, dude? That is insane." So the idea is,
you didn't do any hand motions or anything?
No, I used the voice. And so, but what I'm getting at is that I used what was convenient and applicable for me to use at the same time. Now, when I go back in the lodge, and I want to look up what the conditions are going to be later, or I want to look at the resort's ski lift, what's open, what's not. I don't pull up Google Glass. I'm probably I've got ski boots on. I've got wet clothing on. I just grab my smartphone out, right, and I look at that, and So when we're on the ski bus on the way back home to Portland, I don't. I want a bigger display, so I pull out my iPad. So that's what I'm getting at. And with the advent of the wearable technologies, the smartwatches, so you've got the Motorola product rolling out soon, and LG's products out now that support Android Wear, which is completely compatible with Google Glass. Actually, you can send notifications from Google Glass to the Android Wear device on your wrist, or you can send them the other way from the Android Wear device on your wrist to Google Glass. The high ground of all this is that eventually the technology will fade to the background, and it'll get out of the way, and that people will be able to just express their intent and get information when they need it. And even further than that, there will be context-aware computing that will become pervasive both in professional and consumer spaces, and information will come to you. That's what Google Now is all about. And I see they're very well committed to that because it's smart. Why search for something when it can be pushed to you based on your expressed interests and where you are and what time it is and what's going on around you? So that's a high ground for computing across the board.
This question is probably, I'm digressing a little bit. So Dave, you don't actually tap your glass during surgery, right? It's all voice command, voice.
Right. The challenge with being a surgeon is the sterile environment, so you're not allowed to touch your face or anything that's not sterile. So no, you're not tapping it. You can use head gestures and voice commands and the wink feature for picture taking, etc. But your options are quite limited with how you control glass. So unless you're tilting your head all over the place, looking like you have a tic, or trying to speak over, people in the operating room that may be, discussing whatever, there's the control of glass while maintaining sterility is a true challenge.
Okay. Well, John, I guess you're working full-time on this project, correct?
Yeah, absolutely. We have a startup, tech startup. We're currently going through our initial rounds of funding and getting it off the ground, building a staff, getting ready to build a professional services organization that can deploy this technology globally. So yeah, this is definitely my full-time position.
But you've done startups before, right?
Sure.
So,
yeah, I've been in the technology business for professionally for 33 years, and I've been programming for a total of 35. Started programming when I was 14, so never looked back.
What was your first computer?
I built it.
Oh, really?
I learned to program before there was such a thing as a personal computer. So I was a hobbyist about the same time that the guys in Santa Clara that were building the Apple II and the hobbyists were coming up with these hand wire wrapped and hand built computers. That's what I was doing as well. And we had basically computer geek clubs that exchanged information and parts and spare parts. You hung out a lot at some of the electronic supply places and tried to get them to give you samples of the stuff you couldn't afford and things like that. And so I put it together and I learned how to program. My first language was machine language in assembly, where you're actually loading in binary, typically encoded in hexadecimal, and it's very much a hobbyist thing. And then you step up and you get what we call a BIOS, right? You build your own debugger PROM that is a chip that stores that on, and next thing you know, that's booting up and reading information off a disk. And so as a hobbyist, my first operating system that I ran on the first computer that I built was by a company called Digital Research, DR-DOS. Novell ended up buying them, but it was from a pioneer called Gary Kildall, who didn't end up to be as lucky as Bill Gates.
Was that in San Francisco area?
Yeah, at the time they were pretty much all of the Bay Area. And an interesting thing is, I actually talked with the many of the developers down at Apple at the time, and that Lisa was coming into play. I had also developed a 16-bit system at home based on the Motorola 68000, which is one of the first early 16-bit microprocessors at the advent of the PC industry. And they actually told me, you know what, it'd be really cool if we could give you our operating system. Let us check that out. They got back to me a few weeks later and said, well, we can give you the operating system, but you have to buy the hardware too. And they, of course, had chosen the path to go with a proprietary closed system, and of course they told me I wouldn't get the source code to that as well. But anyway, we digress. I wanted to wrap up by just thanking everybody. Do we have more time here? I kind of lost track.
Whatever. Dave, I'm very interested to hear you talk about the old computer days, because those guys, I mean, they basically built what we're all doing now. I mean, the days of passion, where I don't think any of those guys cared about money. They just loved computing so much, and they probably didn't sleep too much. They just drank a lot of coffee, ate a lot of pizza, and built, what we know are computers today. They must have been an amazing place to be, really.
That's something I can personally identify with. It's my passions run deep and long for this the joy of the computing industry and technology, and I find that the most that I get out of it personally is when I'm solving problems. When I can decompose a problem, I can look at a need that someone has, and I guess that's the most gratifying thing for me in the space that we're in right now, is I know that we're working on stuff that's really important, and it could really move the needle in healthcare and have a very good effect. So yeah, it's fantastic stuff to be working on, and to kind of make your crowning achievement in life. I'm very fortunate to be involved in it.
Well, there's going to be a lot of room in medicine, I think, and a lot of people are going to need help to put their ideas into action through applications. So I think you're going to be very busy in the next couple of years.
Yeah, certainly, and that's one of the things we're trying to do is build a very scalable organization. I mentioned earlier in the pre hangout when we were just chatting and getting ready. We being veteran software developers, all of us having, in fact, our director of software engineering most recently worked for Fortune 50, where he was responsible for approximately $100 million a year in IT spend in software development. Wow. He ran dozens of projects simultaneously, was a hands-on architect and tech lead, hands-on developer, would set up all the projects, hand train the technical leads, bring in new technologies and mentor technologists. And the most important thing to that Fortune 50 client that was spending that kind of money, that was 1/10 of their global spend. Their global spend was $1 billion a year, if you can imagine that. But that's what happens when you get up to that scale. You're bringing in $40 or $50 billion a year. To spend $1 billion of that on IT is normal, actually. IT is a strategic lever that drives business growth and keeps you competitive. But the most important thing to those clients was continuity in the delivery. They wanted to know that they could bring in developers and have a continuous delivery model, not a continuous series of excuses, why we're late, why we're over budget. So it's good, but it goes beyond just the on time, on budget thing. It speaks to the root of quality and how you develop software. And there's a area of computing most recently called DevOps that has merged together the work of the development community and the practices and processes of the development community with the practices and processes of the operations side of IT. Those are the server guys, the IT guys that provision the hardware, that set up the network connections, that set up the firewall rules so that people can safely get information from a secure net out to the internet and back and forth and things like this, and handle all of those concerns. And one of what the result of that has been an area of called DevOps, and a artifact which of that is the process is called continuous delivery, and it involves very sophisticated tools that we use which automate the testing of software as you're developing it, and that's what allows you to scale very quickly. It's what allows you to literally bring in more people, bring them up to speed very rapidly, get them competent within a short period of time, and which is hugely exciting to them, because I've seen developers come into these kind of environments and sit down, and within 1 week, within sometimes the first day, they're coding and they feel like they're a part of the team and they're adding value. And what professional doesn't want to walk into a job, assimilate the tools, and feel like they're adding value as soon as possible, as opposed to the old school, which might have taken a week or two or 3 weeks or a month to get a developer up to speed. And as you all know, it's a very competitive market, so developers come and go, right? They have job opportunities come up, life events, and they want to move somewhere else, another side of the country. They don't really worry about finding work because it's pretty easy to get a job if you're a competent developer. So you have to be able to accommodate all that in your growth model.
Well, you guys are certainly going to be busy in medicine, and I'm sure you're going to improve the lives of lots of people and improve the health of lots of people. So, well, Dave, thank you very much for coming. And
Thank you, John.
I don't know if you know, but Dave was the guy that brought me into all this. He just got a hold of me and says, John, you want to do some hangouts? So I appreciate that, Dave. And John, thank you very much. I'm sure we'll be hearing more from you. And I'm going to sign off here. Just hang around, guys. We'll chat a little bit. Okay, good night.
Thank you, everyone.